Hello class, welcome to Pre-Algebra Lesson 8.1, which is all about functions. By the end of this lesson, you should be able to determine whether a relation is a function and write a function using function notation. Let's jump right into some vocab for you. We have independent variables. Independent variables are values that are chosen. So when I give you an equation in the past and I say, hey, plug this number in, that is an independent. That is what you are putting into the equation. Okay, those are your x values. That is your domain. It's really important that you know all of these words that are associated with independent variable. Dependent variable is the opposite. So instead of the number that you put in, it's the number that you get at the end, right? It's the result. It's the outputs, y values, and range, okay? Make sure if you don't write that down that you have a screenshot that you can reference later on because you're going to need to know that. And function, sets of ordered pairs where each element in the domain, so our x values, those inputs, is paired with exactly one element from the range, the outputs. So if we look at, this is called a mapping. A function, if I have 2 that I'm plugging in, I get a 1 out. If I plug 4 in, I get 3. If I plug 5 in, I get 4. If I plug 9 in, I get 7. Okay, see how they each only go to one number? But over here, in something that's not a function, if I plug 2 in, I could maybe get a 1 or a 3 out, okay? That would tell me that this is not a function because I can get 2 different numbers as my answer, okay? So from a mapping, that's what it looks like. If we were to write it as ordered pairs, in this case, I would say 2, 1, 2, 3, 5, 4, and then 9, 7. Anytime your x value repeats in a list of ordered pairs, that is not a function. Okay? Anytime your x value repeats, it's not a function. It's okay if the y repeats, but the x cannot. All right, then we have just 2 last pieces of vocab. First, the vertical line test. If a relation is a function, then a vertical line, remember vertical means straight up and down, like that. A vertical line passes through its graph no more than once, okay? This is really useful when you're looking at a graph of a function. So we'll test that later, okay? And then function notation. So you guys have seen things that maybe look like this, where we have maybe like y equals 3x, okay? Function notation of that is instead of writing y, I replace y with f of x. That's how you say that out loud. Okay, so instead of writing y, I write this. That is function notation. And it works the same way. Nothing else changes except the looks of it. It operates just the same way. All right, let's look at this first slide here and determine if things are functions. So if I look at letter A, I see I have 5, 6, 7, and 8 for x values. Since none of those repeat, I know that this is a function. So I'm going to say yes. And then if I look at the table, I'm going to look at my x values and say I have a 1, 6, 3. I see that I have another 1. And if I compare the numbers that they are paired with, I have an 8 and a 7. Since those are not the same number, this is not a function. So it's no, it is not a function. All right. So on that first thing, when you're looking at ordered pairs or a table, look for any repeating x values. If it repeats, it's not a function. Then for a graph, we talked about something called the vertical line test, or the VLT. So it means it doesn't matter where I draw a line on my graph, it should only ever go through the graph once. So see how it hits once here, it hits once here, but look, when I draw this vertical line, it hits the graph in 2 places. So this is not a function because it hit more than once. If I look over here, I can see if I draw a vertical line, it hits once, hits once, hits once, hits once, hits once, hits once. So yes, this is a function. Okay? Let's practice changing things from an equation to a function notation. So if I started with y equals 2x plus 3, that would become f of x equals 2x plus 3. If I have y equals 3x minus 9, that would become, instead of y, I'm going to write f of x equals 3x minus 9. The next one, y equals negative 4 plus 6. Instead of writing y, I'm going to write f of x equals negative 4 plus 6. Y equals negative x minus 4. Again, instead of writing y for function notation, I replace it with f of x equals negative x minus 4. So notice I didn't change anything with the equal sign or after. Those all stayed the same. The only thing that changed was that y. That y became an f of x. Okay? So if it asks for function notation, that's all you have to do. All right, let's practice finding a function value. If f of x equals 4x minus 7, g of x equals negative 3x plus 9, and h of x equals 0.5x plus minus 8, then find the value of, we have f of negative 6. This tells you which equation to plug it into, so I'm going to go all the way back to my f of x equation. So I'm going to say f, and then we have a negative 6 right here. I'm going to write negative 6 equals 4, and then anywhere that there's an x, I'm going to replace it with a negative 6. So then using order of operations, this is 4 times the negative 6, or negative 24 minus 7. Negative 24 minus 7 is a negative 31. So f of negative 6 equals negative 31. And then I'm all done with that problem. That's all the farther I have to go. Let's try another one. Okay, so I have those same functions, but now I want to find g of 2. So I'm going to go find my g function, and I'm going to replace x with 2. So instead of writing x, I'm going to put 2. Negative 3 times 2 is a negative 6 plus 9. Negative 6 plus 9 is 3. So g of 2 equals 3. And that is all the farther I have to go on that. I'm done with that problem. All right, our last example for today is a word problem. A whale-watching boat traveled at a speed of 5.5 miles per hour. Use function notation. Okay, so function notation to write a function that gives total distance traveled as a function of time. Use your function to find how long it took to travel 25 miles. So this is 2 parts. We want to write the function, and then we want to know, wow, I mixed up those letters. Function, and then we want to know how long does it take to travel 25 miles. So these are 2 different things. I should not have circled that. 2 different things that we are solving for, okay? So we're going to start with the function. We're going to try to figure out how would we set that up. So if I travel 5.5 miles per hour, if I traveled 1 hour, I'd make it 5.5 miles. If I've traveled 2 hours, I would make it 11 miles. If I traveled 4 hours, I'd make it 22 miles. Okay, so the way that I'm going to do this is I know it's 5.5 times however many hours. So I'm going to use t to represent time. And function notation means that instead of saying y equals, I'm going to say f of, instead of x, I'm going to use a t because that's what I wrote in my equation. So this is my function. That's all the farther I had to go there. And now to solve it, to figure out how long it took to travel 25 miles, I'm going to plug 25 in and then solve for the time. So 25 equals 5.5t. I'm going to divide both sides by 5.5. So then when I do 25 divided by 5.5, I'm left with 4.55 hours. And if I wanted to convert the hours to minutes, or I would say 4 hours, it's okay to leave it at just 4.55 hours, but if you want to convert the 0.55 to minutes, you do 0.55 times how many minutes are in an hour? 60. So 0.55 times 60, and you get 33 minutes. Okay, again, I'll accept either way, 4 hours and 33 minutes or 4.55 hours. Both are perfectly fine. Okay, if you have questions, please ask for some help. I am happy to help you. Have a great day.